Another example of the recursion is the merge sort, right? And actually, we are going to exercise this a little bit in the offline class, but that as a programming concept, it will take awfully long for you to code this in the classroom. So we are going to use some kind of card stack so that we can experiment it, right? So anyhow, so merge sort is one of the sorting concept, and it's you already know the selection sort, so you know the sorting, right? It's just sorting these things out to the descending or ascending orders, right? And the merge sort actually utilize the recursive concept. How to do that? So one thing is decompose into the smaller list and then aggregate to the one larger and sorted list, right? So we have this list of numbers, and we divide this problem into smaller concepts, like this, and then another concept is like this, right? And then we divide it to the smaller pieces, like this and like this. And then the sorting was comparing these many numbers. However, it's now comparing the two numbers, right? And we divide it to the last point. And actually this becomes a turning point of these two. And then we start aggregating, and because we divide it into the smallest pieces, and we now start aggregating by elements. So 3a, compare these two, and then as it as aggregated as 3a, and we compare it 4 and 2, and we aggregated 2 first and 4 later, and 1 6 like this, 7 5. So in the aggregation part, there is a small comparison part, right? And then we are going to aggregate this. So how we aggregate this? So we first compare these first numbers 2, 3, and we put 2 here and 3 later. And then we move to the second numbers here because 2 is now gone, aggregated. And we compare 3 to 4. And 3 is smaller, so we put 3 here and move it to 8. And then we compare 8 and 4. And 4 is here. Now, do we have to compare this 8 again? Actually not, right? Because we know for sure 8 is going to be the biggest number in these two sequences when we are aggregating these two number sequences too, right? So we just put 8 here. So means that we can identify one element without comparing to the another element, right? Same thing happens here. 1 and 5 compared, and 1 goes here and compared to the 5 and 6. And then 5 and 6, 5 goes here, right? And move to here. And 6, 7, 6 is smaller, so 6 goes here. Now do we have to compare something to 7? Actually not. 7 is the smallest biggest number here. So we can just write down 7 here without any comparison, right? And then the same way, we can get the sorted out list. So when we have a big chunk of numbers, then we can divide these numbers into smaller pieces, and then we add up, right? We add up, and then after adding it up, we get the sorted out list. And actually, this is how you can program this merge sort. So I'm just going to pause, recommend you to pause for a second and type these things out, right? Okay, so while you are typing, you must find out something here. And actually, when you are typing, these are the program flows, and this is the execution part. When you are coding this program, you must find out this merge sort is being called within side of this function called merge sort, perform merge sort, right here and here. Means that recursion occurs after the decomposition and before the aggregation, like this. And efficiencies are gained at the aggregation phase. We have been going through that part in the previous slide. What I want to focus on is that how we can program the recursion. What happened was that you had this function here, and within side of this perform merge sort, we have this perform merge sort function calls again within that same function with a slightly reduced parameter set, right? I hope that you typed out these programs by pausing this VOD for a second, because typing is very important in learning how to program, right? So this is the decomposition part, and this is where the recursion happens, and this is where the aggregation happens, and this is the execution code that goes to your main MATLAB main console, and these functions goes to the MATLAB script editor, right? So let's go back to the Fibonacci sequence example, because it's the easiest one and simplest one. And if we want to compute F4 here, we have to compute F3 and F2. To compute F3, we have to compute F2 and F1. To compute F2, we have to compute F1 and F0. Same thing here. Is there any problems in the recursion? Actually, there is. There is a certain excessive function calls. So we just want to find out F4 here, and we have to call these many functions. Means that we have to learn the many calculations, and it's time consuming, and the time is golden, and we want to get rid of this excessive function calls, calling the functions again and again, even though the function is executed before with the same parameters, right? So here we are going to call F4, and we are going to call F3, and we are going to call F2, and we already called F2, and we can reuse this result here after here, but this recursion program will call this F2 again. So it has two repeated calls of the F0 here and here. It has three repeated function calls of F1 here and here, right? It has two repeated function calls F2 here, right? And this can be just called one time, and if we just store the result properly, then we can just reuse the program, the result again and again without calling that function again, right? So these are unnecessarily taking time and space. How to solve this problem? As I said, if we just stored this result, it would be much easier and much faster to utilize that function, the result, again. And we have to store these values, right? And that's how we do that in the dynamic programming, all right? In the dynamic programming, we store these values, and we are going to reuse it. And actually, that's the essential concept that differentiates between the recursion and dynamic programming, right? And that's the storage facility to memorize this function call result is called memoization table. And we are going to all go through these concepts and the programming of this dynamic programming approach in the next part of this BOD lecture. And do remember that programming is the self-learning process. You know what this? If you can speak English fluently, not fluently, but if you are able to speak English, you must understand that you have to explain how to pronunciate, how to make a sentence, how to write down a words and sentences in the grammar structures. You must know that you have to do it by yourself. There is a certain limit that textbook and the teachers can teach. So there were like the Fibonacci sequence program here, right? Here, and then there was this merge sort example here. So I just recommend you to after you are done with this BOD, you go home and you do your programming typing, and that's what I recommend. Okay, so that's the end of my lecture, and see you in the next part of this week. Okay.